Hey guys, my name's Dylan with Hydronic Mechanical Services. We're headed over to a service call. It is a boiler. It's a new customer. I guess he's a house flipper, and he just wants to get the system checked out before they put the house on the market, make sure everything's working properly, make sure everything's safe and ready to go for the new homeowners. In this video, I will explain what I do when I go out and inspect a boiler. Just got a new work fan. I gotta get it logoed. I don't know what I'm gonna do yet, but if you guys have any recommendations, send them my way. Okay, so it looks like we are working on a 1979 Burnham, just a standard efficient boiler. A little bit older, but cast iron boilers last a really long time. So anytime we do a boiler inspection, we check all of our fittings, see if we can see any kind of buildup, like around this valve. Kind of see right in here. It's been leaking. We might be able to just tighten this up and get that leak to stop. We'll try it. It's a very small leak. It's not active right now. Over here we have another one. This is basically called a gate valve. You can tighten this up, and there's what's called packing inside of here. When you tighten that up, it'll actually kind of help stop that leak. These are old valves, but we always kind of want to check around, make sure we don't have any pipes rubbing together. You can kind of see right here where that pipe has been kind of rubbing against there. Vibration, eventually will wear through that pipe and cause a water leak. So up there we have our thermal expansion tank. This is kind of an older style expansion tank. They used them back in the day. Now they use more of a bladder style expansion tank. The expansion tank's basically used for thermal expansion. So as the water in the system gets hotter, the pressure is also going to rise, and that pressure needs somewhere to go. Without a thermal expansion tank, our pressure relief valve would blow off as the boiler water, the temperature of the boiler water increases. These are normally set for 30 psi. Right back here, we have our main circulation pump. This is energized when we get a call for heat, and is what circulates the hot water throughout the house and through all the baseboard heaters throughout the house. This one only has one pump, and we do not have any zone valves. So basically, there's one thermostat in this house. When we get a call for heat, that pump is going to start up, the boiler is going to run. So right here is what we have is called an aquastat. The aquastat is used to control the temperature of the water in the boiler. It's basically a little dial back here that you can adjust. Right now it's set to 180 degrees, which is normal for this size boiler. So once the boiler gets a call for heat and this temperature probe is reading less than 180 degrees, the boiler will fire up to heat up that water, so it will reach that set point. There's a transformer in there, a little contactor. We have some wires. Our circulation pump is wired into here, and our thermostat wires also ran into here. There's also some wires that run back to our controller inside the boiler, which is used to ignite the pilot light. There's also the flame sensor is connected to it. So basically our thermostat comes in here. When we get a call for heat, it's gonna tell our temperature switch that there's a call for heat. Temperature switch will close, energizing that contactor, which will tell our controller that there's a call for heat and the boiler needs to run. It's also going to start our pump. So right here is our gas valve. Standing pilot is normally when you'll have to light your pilot manually. You'll have to basically use a lighter, push a button on the gas valve, and start your pilot. Right back here, we're just a little skinny probe-like thing, that's our flame sensor. So when that pilot light starts, it's going to heat up that flame sensor and send a small electronic signal back to the gas valve saying that the pilot light is lit. If we do not read flame on there, we don't want the gas valve to sit there and keep pumping gas into the boiler or into the burner compartment, and then all of a sudden ignite, and then we have bigger issues. These are pretty common to get really dirty. Even this one is pretty dirty and probably should be taken out and cleaned. If they get really dirty, it won't read flame, and then your boiler won't run. Right down here are our burners. So there's tiny little holes in there. The gas is pushed out of these tiny little holes, these gas orifices, basically pushed into our burners, and then the small holes are right there. The pilot will light those burners up and provide our flame. Right here is our heat exchanger. The heat exchanger is used to exchange the heat produced by our burners into the water. Basically, water is flowing through our heat exchanger and getting heated up and then pumped throughout the house. Right here is our exhaust. So that is exhausted up to the roof and is also tied into our gas water heater. But as that exhaust heats up, the exhaust is actually going to be pushed out of the house. When these are cold, sometimes you'll get kind of some back carbon monoxide that'll come out. So that's something to kind of look for. Right up here is what's called our fill valve. Backflow, well, they put a check valve in. Normally you want to see a backflow preventer installed. The fill valve is used to fill the boiler up to a specific pressure, water pressure. Normally I like to see it between 10 and 12 when the boiler is cold and not running. Right here, a check valve. We don't want our boiler water to backfeed back into our drinking water, or if we drain the house, we don't want all the water to be drained out of the hydronic system. I would recommend replacing that check valve with a backflow preventer. Fill valve looks okay. These are Caleffi fill valves. The Watts fill valves are normally my favorite, but I like these ones too. You can kind of see on our brass, sometimes we get a little bit of pitting. That's normally caused from a tiny water leak. It's sealed itself, but definitely make a note of it. Right back here we have what's called our pressure relief valve. That is set at 30 psi. It's not like your normal water heater relief valve where a water heater relief valve will blow off at pressure and at temperature. Right here is our main power switch. This is used to turn the high voltage power on and off to the boiler. We're gonna turn that on. I actually jumped out the thermostat just for a second, because there's no thermostat in the house. Okay, so we'll kind of watch this go. So you'll see at first our pilot light is gonna light. As soon as that flame sensor sees that there's a pilot light, the burners are gonna start. And that is heating up our heat exchanger, which I don't want to get too close, but that's what's gonna heat up the water, which is then circulated with that pump. Right here we have our copper baseboard heaters. You can kind of see inside of here we have aluminum fins with a piece of copper that runs through there. So these are basically going to radiate the heat that is produced by the water in the boiler. And these are located throughout the home. So I always like to check. So right here where our pump is, we have a little arrow on here, right there, just facing up. So our pump is pumping water up through our copper, which is then brought back into a loop, comes back into this side of our boiler. I usually like to kind of feel the temperature of this line as the boiler's running, just to make sure our pump is actually pumping water through. If you start feeling this line's getting hot, then we know we have flow, which is definitely heating up. So right here, it's kind of another view of our exhaust. It's double wall piping. We definitely want double wall whenever we're close to any kind of 2x4s. The double wall is going to kind of help keep that heat inside of the exhaust rather than kind of near all this wood. So whenever you're at a house or anything, it's always good to, you know, just check out everything near the boiler room. Make sure you don't have any water leaks. I think we should probably get rid of this saddle valve. Doesn't look like it's being used anymore, and these things leak all the time. That union's a little rusty. Looks like this water heater was put in 2016. We don't have any kind of thermal expansion tank on here. I always recommend having an expansion tank on the water heater. So kind of a quick summary of what I think should be done on this boiler is obviously a good cleaning, get all this dust wiped off of here, pull all of our burners out, you know, kind of clean those all up so they look nice and pretty. Clean up that flame sensor. It's a little dirty, definitely needs to be cleaned. I don't think it's at a point where we need to replace it yet. Definitely gonna recommend doing a new temperature pressure gauge so that way we know what our temperature of the boiler is and what our pressure is. I'm gonna recommend that we replace this valve. Just it's corroded, an inspector sees it, he might dock that, say, hey, you know, you guys have a leak, probably should get that replaced. I'm going to recommend them install a backflow preventer, get rid of this check valve. Fill valve is still fine, so we don't need to do anything with that. I'm gonna recommend they install a new thermal expansion tank. This one's just outdated. The new ones work a lot better, and we don't really know what it looks like on the inside of it. It's pretty rusted out. And yeah, just do like a good thorough cleaning of this thing. I may also recommend that we remove that saddle valve. Just get rid of that, put a coupling in there. It's also kind of a small line for, yeah, that's our cold water. We're doing a 1/2-inch line on our cold water, which is kind of crazy. We normally want to see that more of like a 3/4. Looks like they have some pretty old piping in this building, or in this